Good day everyone. I'm Akshat Gunashilan presenting the paper ID 91 with title SVMJ, a strategic model for recommending videos concerning mobile journalism. This paper is done by Akshat Gunashilan and Gerard Deepak. Abstract. The evolving landscape of Web 3.0, marked by enhanced cohesiveness and data density, lacks comprehensive frameworks for video recommendation, particularly in niche domains such as mobile journalism. This paper introduces a robust strategic framework to address this gap, specifically targeting the unique domain of mobile journalism. The framework employs a sophisticated learning strategy combining convolutional neural networks (CNNs) and decision trees (DTs) to balance computational load and optimize the video recommendation process. One of the essential features is the ability to synthesize data from standardized knowledge repositories such as Wikidata, NEL, COIC, and knowledge graphs, enriching the recommendation process with auxiliary knowledge. To enhance semantics reasoning and recommendation quality, the framework utilizes metrics such as the Jiang-Conrad Similarity Index, Simpson's Diversity Index, and the Generalized Entropy Index. Operating as an incremental model, it captures knowledge from both query and dataset ends, resulting in top-tier recommendations for mobile journalism videos, achieving an overall precision of 95.09%, F-measure of 96.47%, and the lowest FDR value, which is the false discovery value, at 0.05. Recommendation frameworks in Web 3.0 offer personalized suggestion based on user data, aligning with decentralization and data ownership principles through blockchain solutions. Web 3.0 emphasizes on structured data and metadata, improving content understanding and search capabilities, particularly for video recommendations. Enriched metadata enhances precision in video suggestion, contributing to a user-centric video ecosystem with decentralized control over data. Platforms such as YouTube, TikTok, and Instagram Reels, driven by video recommendation algorithms, have become essential for today's entertainment, education, as well as information. In mobile journalism, recommendation algorithms aid journalists in finding relevant stories and sources, thereby improving reporting while delivering personalized news updates to consumers, fostering news accessibility and engagement in our mobile-centric world. The main motivation behind this model and paper was the evolving landscape from Web 2.0 to 3.0, and where there is a critical need for a recommendation for video framework tailored to the new era. Web 3.0 brings decentralization and semantic paradigms, demanding innovative video recommendation approaches. Conventional techniques fall short, so it's vital to shift focus to web structural metadata, ensuring compliance with Web 3.0 principles in the framework. Contribution. The following are the novel contributions that are provisioned by the SVMJ model. Strategic entity harvesting from knowledge repositories and graph augment dataset entries, enhancing knowledge modeling. Specialized video recommendation framework designed for mobile journalism addresses information systems gaps in this specific field, utilizes a combination of CNN and DTs to balance cognitive load and classify video datasets, achieves convergence through an isolation index in the classification process, employs semantic reasoning with the Jiang-Conrad Similarity Index, Simpson's Diversity Index, and GE's computation in a novel semantic similarity mechanism. The base paper for this paper was the paper written by Gong et al. This paper introduced a pioneering strategy for real-time short video recommendation. To enhance prediction accuracy, they deployed a compact on-device ranking model on mobile devices and introduced a context-aware re-ranking method using adaptive beam search. This approach has the potential to revolutionize real-time short video recommendation, and it is quite effective. Another paper which was used was the Zhu et al. This paper addresses a common limitation in video recommending systems heavily reliant on metadata. They present the video topic framework, which employs a topic model to improve content-based video recommendations. Their research rigorously evaluates the framework's effectiveness using experiments on the movie lens dataset, assessing individual components and overall performance. The third one is by Yoshida et al. This paper explores context-based video recommendation and introducing a novel approach. The context trees which have been derived from the browsing behavior of the user would definitely yield to underfitting, and there is no strong learning in this framework, and the semantics as well is a little weak. The proposed system architecture. This is the proposed system architecture of the SVMJ model. There is a dataset of videos which follows three different paths. The first path is the dataset of videos. The videos are used to extract labels, and then they are enriched using the Wikidata API, and then they are loaded to the entities. Same thing happened with extraction of categories, and then enriched with the NEL API and Knowledge Repository API, and then the entities are loaded. These two are used to generate knowledge groups using Google's KG API, which is a knowledge graph API. Those two are used to compute the Young-Conrad Similarity Index, and then they are sent to the rank and recommended facts. Similarly, the second path is for the dataset of videos is used for classification using the decision tree DTs, and then coverage of classes using isolation index. And the third path is you classify using CNN, and similarly coverage of classes using isolation index. And then the common relevant instances are extracted from the dataset, and this is used for computing generalized entropy index, as well as computation of generalized entropy index, which is used to again compute Young-Conrad similarity index and then used for ranks and recommended facts. Similarly, the user input is then taken, query processing happens, query work happens, and then they are used to compute Simpson's diversity index, which is again used to compute the Young-Conrad similarity index, and this finally yields to ranks and recommended facts. As we see, this is a complex process which is used to for ranking and recommended facts, and uses a three-way architecture which is used for enrichment of the data, and this is why the results obtained by this model is the best in class compared to the other models which are compared in this particular framework. Implementation. The main implementation language for this particular framework was the Python language. The IDE was the Google Colab IDE. The datasets were scrapped from Kaggle. The dataset which was used as a single large dataset constituted from three major independent datasets. The first dataset is the NYC Media dataset. The second dataset is the Singapore 2019 mobile device usage for media activities dataset, and the third dataset uses the mobile phone and media diaries 1999 and 2001 dataset. In the SVMJ model, the performance metrics are calculated as follows. The accuracy is calculated at precision plus recall divided by 2. Precision equals equal to the number of relevant and retrieved videos divided by the total number of retrieved videos from the query. Recall is equal to number of relevant and retrieved videos divided by the possible relevant videos. The F measure is calculated as 2 into recall into precision, the whole divided by the recall plus precision. The false discovery rate is equal to 1 minus the value of the precision. Precision percentage versus number of recommendations. This graph shows that SVMJ, which is the proposed model, has the highest performance compared to the PRMA video topic and TSAR model, as already discussed in the related work section. As we can see, due to its high enrichment of data and semantics orientedness, SVMJ performs better than all the compared best models, and is the best in class model for video recommendation, especially in the niche domain of mobile journalism. As we can see the performance analysis of the SVMJ model, the proposed SVMJ model has the highest average precision percentage of 95.09, highest average recall percentage of 97.89, highest average accuracy percentage of 96.49, highest average F-measure percentage of 96.47, and the lowest value of FDR of 0.05 when compared to the other baseline model as shown in the graph already. Conclusion. This model introduces a strategic framework for mobile journalism using video recommendation, leverages data from Wikidata, NEL knowledge stores, and Google's KG API for knowledge enrichment. It utilizes dual classification with CNN and DT classifiers, leading to improved accuracy. It incorporates advanced techniques such as query word extraction and semantic reasoning. This model achieves impressive metrics including 95.09% precision, 97.89% recall, 96.49% accuracy, 96.47% F measure, and a low FDR of 0.05 positioning the framework as a leader in mobile journalism concerning video recommendations compared to the other baseline models. Thank you.